Go ahead, John.
Alrighty. Hello there. Welcome to Indie Game Academy, important game dev lessons. That is student run, and this is dynamic game aspect ratios and borders, or how to maximize screen estate if desired. Video games require a good deal of techniques to bring an enjoyable and playable experience to players. User interface and screen size are major aspects in video games since resolution, aspect ratio, and orientation will dictate the game core loop. I'll show you various ways aspect ratios are handled for video games. Then I'll show you my approach for handling varied aspect ratios and resolutions. The origin of how aspect ratios came to be are visual mediums, first being drawings like paintings and pictures, then come photography. And then when the visual medium has moved forward, there came a series of captured photos to create animations such as moving pictures. Paintings and drawings were earliest visual medium that eventually been used on rectangular canvases to capture the whole subject and basis for succeeding mediums. Moving pictures and drawings evolved from pictures that are designed to be viewed at a rapid changing sequence. This paved ways for drawing, animations, and movie cameras. They both have diverse aspect ratios that are designed to get the viewer to look at any point. When movies, they have started out as small boxes that gradually expand in width to increase the viewpoint so audiences can find details at edges along with the center. As you can see from bottom to top, there's an increasing aspect ratio on the width. And the only movie to ever have 4:1 aspect ratio is Napoleon. I want to point that out since that makes a very, very wide shot and it requires multiple cameras to make it seamless. Video games are the latest evolution of visual audio medium with interactive elements and through input machines and programming logic. Due to the interactive nature, aspect ratio and orientation heavily influence the gameplay experience, ranging from horizontal monitors to expand game landscape to vertical monitors that encourage concentration on character movement. Sometimes there are games that utilize square to round screens to evenly distribute gameplay field. And it's very rare to find video games that have a truly 1:1 aspect ratio. Star-Lords and Warlords are examples that utilize 1:1 aspect ratio in gameplay field, whereas other games are content with having widescreen monitors and others with vertical orientation, such as mobile games of today and arcade video games of the past. And so that's what video games are when they utilize their full resolution capacity. However, that is not often the case. But here you can see that in various games that have been ported to other systems, additional black boxes are there, whether it's by ports or emulation or whatnot. That's where they add in the extra black borders, making it not possible to utilize the whole screen real estate. Some have black borders, while others have additional UI gadgets to bare minimum UI gadgets to indicate gameplay logic. Vertical games are most likely to impacted by that, since horizontal displays rule the day. Here, I'll show you the wrong way to address the aspect ratio discrepancy. Stretch or squish to fill. Wrong. In the early days, there are game systems that did not have very consistent pixels, and they are not often square pixels for 1-to-1. They're often rectangular pixels so that they can match within the cathode ray tube television sets or cathode ray tube monitors. But in today's world, they are dominated by LCDs, and having any configuration options to stretch or squish to fill, it's a very wrong way to fill up the whole screen, as it can mess up visually and make it difficult to view the game world without its correct aspect ratio. And you are free to ask any questions throughout the lecture. There are many ways for video games to utilize empty space when the game is not entirely full screen by design. Look at methods to address the empty space on display. The easiest solution is having black border boxes. That allows the game aspect ratio to be consistent. Do any of you remember playing those video game compilations, and in the collection you notice games that have both horizontal and vertical orientations? If you do, then vertical games are more likely to have empty black borders than horizontal games, since consumer devices have horizontal aspect ratios. But with a black screen border, there's nothing to really look at. Let's go towards the next step. Almost easy, adding decorative borders. Decorative borders are like black boxes, but with pictures. They can be used to convey a theme related to the game, and also they can be neat decorations to stare without being bored from black boxes. As you can see, having a background picture is an easy way to keep people on the hook to play video games when they're not at their full resolution. And some games even have this gameplay window as a camera, and then there's the other background as the second camera. Again, vertical games are more suspect to solving these aspect ratio problems. And so, if you're not content with simple pictures, what is the next best thing? Challenge: fitting UI elements outside the gameplay screen. For games that require additional data to be displayed that should not interfere with the gameplay screen, it's possible to add them at border areas. It happens quite commonly with shooting games, also known as shoot 'em up, since many notable ports to those models are vertical, and horizontal displays with vertical games can liberally experiment with additional information outside the game area's aspect ratio. As you can see on some of them, they have additional gauges outside the borders, outside the gameplay window, since they cannot really fit in the gameplay screen without interfering the gameplay field. And there are some that have utilized the empty space to fill in with decoration and put all essential information on the side. Gauntlet is a 1-to-1 aspect ratio gameplay screen, but the monitor is 4:3, so they have this 1/4 of the screen occupied by 1/4 to 1/3 of a screen occupied by the additional data. And for mobile games, vertical ports onto vertical devices like mobile, they have borders and they put in additional things such as controls and things. But what if there was one more step above adding information. Ah, extreme. Fill up the borders with dozens of UI gadgets. M2 shot triggers is
Gosh.
notable for having a series of UI gadgets that display an extensive amount of information. Makes it entertaining to read for dedicated players, but may be initially off-putting for newcomers. And it's not only that, other modern games utilize the empty spaces and fill it with relevant UI gadgets. Recent Exa Arcadia games like Dodonpachi Saidaijo Exa label has these UI gadgets as inspired by the M2 shot triggers. So that's how you can utilize empty space to fill in additional information. But with mobile games, it is very important to consider modular aspect ratio. Consider the base aspect ratio and adjust the screen to fit all gameplay elements on the screen smoothly. As you can see, some games have, there's the default aspect ratio, and there are the default aspect ratio has these black screens, and then there are games that utilize, and when they are zoomed out, it's like some information are maintained, whereas others is like they have to keep the UI consistent and only the background really changes, so it's easy to read all gameplay information. But there are others that simply like zoom in and out of these gameplay elements and the UI, which Unity does have support for aspect ratio design. And now, one common way to allow people to adjust the resolution aspect ratio are display options. They are common on PC games, but are often fixed to one aspect ratio. As you can see from the pictures below, you have lots of options to adjusting your video settings. And with the window settings is the Windows settings is the one that's responsible for resolution and aspect ratio, amongst other things. Do you have any questions so far before I move on to how to utilize the game aspect ratio configurations? If so, no questions? Well, I'll move on then. And now, with that in mind, I decide to create a small prototype that allows dynamic aspect ratio settings on game screen and display through Unity. There is a free asset that is essential for allowing dynamic aspect ratio adjustments to occur, and that is LetterBoxer. This asset provides automatic sizing that matches the target game aspect ratio, and I will post the link there in the chat. And this is where, and that's where how I managed to utilize, that's where I got this free asset. As you can see below, there are examples on the game design for this aspect ratio, along with the incorrect way and the correct way. The incorrect way is without LetterBoxer, and the correct way is to use LetterBoxer.
I have a question, John.
Yes.
Don't you deal with aspect ratios by using anchors inside Unity?
That's the key point. That's key. You have to utilize anchors smartly, and that's up to the developer and designer to use those anchors correctly. and they do play a big role with dynamic aspect ratio adjustment. But for now, I'm going to focus on the inner code structure that does dynamic aspect ratio.
Okay.
And so, for the dynamic aspect ratio settings to work, we need two cameras and canvases, one for gameplay screen and the other for background border screen. The gameplay screen is what we use to maintain a consistent scale without having to stretch or squeeze. That is also the game screen to put in all essential gameplay UI that should be readable to players when subject to aspect ratio border boxing. The background border area was essentially a decorative background. The simplest implementation is having a background image that repeats the pattern, or is large enough to cover the size of the border background camera. Both cameras will use LetterBoxer asset for the cameras. The UI canvas is more challenging as it will involve dealing with diverse aspect ratio scalings, which we'll go into later. Before revealing the implementation, you need to be aware of its caveats. Rotation of the camera and canvas behave differently from simply the sign of rotation. For positive, camera rotates clockwise, while UI rectangles like canvas rotate counterclockwise and vice versa. For negative values, the best way to address the situation is to keep a consistent rotation value that applies. The best way to address the situation is keep a consistent rotation value that applies to both canvas and camera. And that can be achieved by keeping rotation value absolute positive as easy maintenance. Also be aware that canvas cannot be rotated since canvas acts as a root to all UI elements, which they can be rotated. Strongly recommend to create a grid layout panel with one cell that acts as an aspect ratio adjuster, which the code will be revealed soon. Another caveat is that Unity cannot refresh display settings instantly because the changes are not instant from programming. They cannot change perfectly per frame since canvas redrawing can be intense. Instead, the use of coroutines are required whenever any display resolution or UI canvas aspects are changed, including but not limited to the following, like coroutines and camera like any UI, which includes but not limited to any runtime UI changes, display screen render change, camera display view box change. Camera rotation does not need coroutines, since the rotation updates within one frame. To be on the safe side, using a coroutine for camera view box change would be a good idea since we need to adjust the user interface aplenty. I'll show you each aspect of the dynamic aspect ratio with some code samples to understand the inner workings. There's a lot to unpack from this dynamic aspect ratio configuration. I made this as a prototype to explore aspect ratio configuration. The first one is game screen rotation. That is a very easy one. As you can see here, it doesn't involve much. So all you do is rotate the camera by the angles and pay attention. Those angles have to be opposite, like minus angle for camera rotation and positive angle for UI rectangle rotation, because if you do that, if you have both of these as positive, it'll just go whoop. It'll look crooked and upside down.
I'm
The
sorry, John.
UI
What was
may be
that?
upside down, or the camera may
What?
be right side up, or the camera may be upside down, but the UI is right side up. You said something?
That's okay. Continue. I was just making a joke. Okay.
Yeah. Anyways, that's a thing to keep in mind. Always have rotation of UI and camera at opposite, choosing one as negative and the other as positive. As I said, this is what the caveat of camera rotation, as I explained earlier. Remember, clockwise and counterclockwise have opposite values for camera and UI rectangle. And if you're going to have the comparison of rotation angle, I recommend that you convert to absolute value for comparison. That will be necessary for future comparisons and aspect ratio scalings. Display resolution. That gets dictated by the display aspect ratio and also the full screen. The display resolution simply sets the display window resolution in pixels. It does not deal with any object rotation or game aspect ratio changes. The developer must implement such logic. However, there is also display aspect ratio that dictates the display resolution, but we'll cover intricate details on aspect ratios later. Do keep in mind that when clicking on full screen button, it zooms in based on a display resolution, which brings black border boxes and fuzzy pixels when not setting the display configurations correctly. And again, like the rotation, the display resolution is very simple. You set this resolution based on the current display resolution, as it may be it can be a vector 2, or it can be a simple resolution. It's a vector 2, by the way. And then there's the full screen toggle Boolean. You said a question?
I don't think there was a question.
Anyways, that's one of the easy parts. And now we get to the most difficult part of the game screen configuration, the game aspect and display aspect ratios. The dynamic aspect ratio configuration involves two kinds. The game aspect ratio is the gameplay screen containing all essential elements, especially essential game UI. The display aspect ratio is display screen with additional borders not covered by the game screen. You need to consider rotation of the game screen since it's possible to support any desired orientations. For instance, you have 3x4s and 16x9s, and it is possible to have it rotated. So let's begin with the LetterBoxer. We use LetterBoxer's code to adjust the game screen's view box to scale either the width or the height of the display screen based on the aspect ratio difference. Should the display and game aspect ratio be the same, then the game screen will take up the entire display. To ensure the game window works seamlessly on any aspect ratio, I added in the target orthographic size, which adjusts the camera's view height. It's very important that the rotation value should be considered when dealing with orthographic size while setting up the game's aspect ratio. Because if you don't include the target orthographic size, then it's going to mess up. And I primarily did it as a 2D game concept. 3D games I have not really explored, but someone will have to make the appropriate code for handling aspect ratios in a 3D game space. And this is a current viewport, and this is viewport height should be scaled by this amount. Then if scaled height less, you do either a letterbox or you add in the if scale. You calculate the viewport height. Then if scaled height is less than current height, add letterbox. Else, if scaled width is less than current width, then add pillar box. That's the LetterBoxer code that comes from the LetterBoxer asset. And the next part is, after adjusting the canvas scaler, then we adjust the UI screen's grid layout single cell size to allow UI elements to fit in. That is where the anchors come into play, since you have to make sure that you target your aspect ratio to fit with the anchors. Only then, when you adjust the game UI, then it comes seamless. It is very urgent that for the UI display options, we're not expecting to change. It is very urgent that for UI display options, we're not expecting to change on the fly. Add in the code to refresh content fitters along with wait until end of frame so that it can properly adjust the correct gameplay aspect ratio. As you can see here, I made this reference resolution deliberately a square for the canvas scaler, and then I have the screen match mode set to match width or height. And I put in code that changes the match mode width to height to match the aspect ratio correctly. After setting the grid display UI boundaries, the final step is setting up the aspect ratio scaling for the user interface based on gameplay area and display screen aspect ratios. The typical calculation for aspect ratio in float is width divided by height to make display aspect ratio equations easier. The biggest challenge is setting up the scenarios for various cases. First, check to see that both are either horizontal or vertical, which helps with UI scaling adjustment. The primary determinant of UI scale is based on making the aspect ratio a quotient that's guaranteed to scale down, as in the quotient should always be less than 1. As you can see right here, that the other aspect length, if the aspect ratio is less than 1, then you divide it by the aspect ratio. Otherwise, if it's greater than 1, multiply. That's to ensure a consistency. And that equation's very important for setting up the calculation. And so, after that, so that whenever the game screen shrinks to fit the display, the UI elements will then fit in place. Next, we also check that the rotation is present. Rotation in this case is when the game screen is rotated either clockwise or counterclockwise once sideways. Rotation is considered false when rotated 180 degrees, making it upside down, but the same aspect ratio as no rotation on display level. The reason why I restrict rotated to being rotated clockwise or counterclockwise once is that orientation affects aspect ratios. And now we move on to the next step. And now we check that the UI scale when the screen is rotated or not rotated. We check this one first. We check the is rotated part and we do this configuration. The two important, as we can see, there's the game aspect ratio scale, and then there's the display aspect ratio scale. It's very important to do so, have these two scales, so that way it's possible for the game UI to fit the game screen to fit appropriate game screen and UI to fit appropriately.
More damaging earthquakes than any other area of
Huh? Anyways, else if it's not rotated, then you check the float value that the game that it's approximately equal, then you scale the UI elements to match the entire display screen. Else, if both horizontal, then you check that the display aspect ratio is less than the game aspect ratio, then you scale according to display. Else, you have it full. Both vertical is when display aspect ratio is greater than the game's aspect ratio. And you then scale the UI elements to display. Otherwise, don't. Else, if it's neither both horizontal nor vertical, then you scale the UI elements by multiplying both the display aspect ratio scale and the game aspect ratio scale. After all conditional calculations are done, we then scale the UI screen to match with the game's area aspect ratio to achieve consistency. And now that we covered all the parts of adjusting the game screen aspect ratio adjustment, one step to polish the dynamic aspect ratio is utilizing UI elements at the borders to demonstrate great potential in dynamic aspect ratio UI design. See the background borders and there's sample UI. I'll show you how it's done. To achieve border UI information at the leftover spaces, implemented Boolean values to check rotation, camera rectangle width and height, and border display modes, pillar and letterbox. Those Booleans are required to ensure that the correct border information are present. Once again, after that, I put in various grid layout groups to represent extra border space for additional optional UI elements. So basically, it's a rule of threes. You have 3 columns / rows. For the letterbox, you have 3 rows, with the center being the game aspect screen, And for the pillar box, you have 3 columns, and the center column is always going to be the game aspect ratio. And like the LetterBoxer, if it's full screen, then don't activate border boxes. If it's pillar mode, then you activate the pillar box. If it's letterbox mode, activate the letterbox. And then you do a content filter refresh, and then call the wait until end of frame and such. Like the last UI aspect ratio, the canvas scaler is used to match the width and height once again. But the background border camera takes the entire display, so the decorative border always appear behind the game screen. And once again, after you calculate all this stuff with this pillar mode and letter mode, then you adjust the grid UI cell side that is based on the grid layout. And the stuff works. And now that I've showed the programming process behind some code, I'll showcase the video of this dynamic aspect ratio. As you can see, this prototype actually adjusts the game screen and aspect ratio on the fly while maintaining a consistent gameplay field. Feel free to ask any questions if you have any. And it's also possible to rotate the game UI so it can support any aspect ratios. So it'll be easier to develop games that you have in mind, such as vertical games, horizontal games, or a multi-aspect ratio games. If anybody's able to make this kind of stuff, it'll make game production much easier for targeting various platforms. And yes, whenever the display aspect ratio is changed, the display resolution is set as well, which means that it's very easy to adjust the resolution without having to go through the entire smorgasbord of options. Anyways, that is it. Feel free to ask any questions or comments about this dynamic aspect ratio and UI fitting.
Woo, good work, John.
So
John, will you be able to share the code from the presentation on GitHub? Or is that the link you posted?
I did post a link to the free aspect ratio, the LetterBoxer, which I used its code as a basis. And I do plan to upload that to a separate GitHub repository, since it's very basic and bare bones enough that willing to share it, and that will be used to help understand how things work.
Great. Okay.
I want to load that, but then it's like I keep forgetting. Any other questions about game aspect ratios and stuff? Feel free. Now's your chance.
Well, my other question comes from my kid stopped kicking the door, so I'm okay to talk now. My other question is going back to the anchors. How does the anchors come into play with these ratios?
Oh, good question. Anchors are primarily used to set the user interfaces, and you have to plan for which aspect anchors are used to set the places for these UI elements. And whenever you change the gameplay area's aspect ratios, the UI will scale and reposition appropriately. As you can see from this video again, all the UI elements are basically attached to anchors. You see? You see they adjust in a UI and they all fit together? You have to use anchors smartly. Does that answer your question?
Kind of. Maybe it's something that you and I can talk about later, but I think it'd be good to maybe go over about how anchors are used because they can get kind of confusing.
Yeah, I'm gonna have to make some sort of a subject on that since anchors are a big thing. And I too had to organize about, had to toy around with anchors. It is possible to adjust all the anchors manually in code, but to make a quick prototype, I utilized 4x3 and 3x4 as the basis because that's closer to a square. And you can see that the game UI shrinks and resizes appropriately in my prototype. That was the most difficult challenge of them all. As soon as I have solved this through this equation, through the algorithms of changing the user interface, that becomes much easier to adjust the user interface.
Okay.
Any other questions for me?
I don't have any.
Yeah, I think we're good. Okay. In that case, as long as everybody's good, I'm gonna go ahead and stop the recording. Thank you very much, John, for doing this.
Yeah.
And yeah, I will share the recording once it's all uploaded to the cloud.
Thanks,
Right
John.
on.